The Earth is surrounded by a layer of gases known as the atmosphere. It protects life from harmful solar radiation, regulates temperature, and provides the air essential for breathing and flight. Although it extends thousands of kilometers, most of the atmosphere's mass is concentrated close to the Earth's surface, making it extremely thin compared to the size of our planet. Composition of the atmosphere. It consists of approximately 78% nitrogen, 21% oxygen, and 0.93% argon. Carbon dioxide forms about 0.04%, while trace gases include neon, helium. Gases are uniformly mixed, a region called the homosphere. Above that lies the heterosphere, where gases stratify according to molecular weight, lighter elements like hydrogen and helium rising higher. Certain gases such as water vapor, carbon dioxide, methane, and ozone absorb long-wave infrared radiation emitted by the Earth's surface. This natural greenhouse effect keeps the planet's average temperature around 15 degrees Celsius, making life possible. However, an abnormal increase in these gases enhances the effect, resulting in global warming. Water vapor is the most variable component of the atmosphere. Warm air can hold more moisture, while cooler air becomes saturated, leading to condensation, cloud formation, and precipitation. Humidity, therefore, directly influences weather, cloud development, and aircraft performance, since moisture affects both air density and engine power output. Carbon dioxide, CO2, though present in small amounts, plays a vital role. It is produced by respiration, combustion, and volcanic activity, and absorbed by plants during photosynthesis. The balance between CO2 production and absorption regulates the Earth's energy balance and supports vegetation growth. At altitudes between 20 and 30 kilometers, the ozone layer resides within the stratosphere. It forms when ultraviolet radiation splits oxygen molecules, creating ozone that in turn absorbs most incoming UVB radiation. Without this protective layer, intense UV exposure would endanger all living organisms. Dust, pollen, salt, smoke, soot, and industrial pollutants. These aerosols scatter sunlight, color the sky, and act as condensation nuclei for cloud formation. Excessive concentrations reduce visibility and contribute to smog and air quality hazards. About 99% of the atmosphere's mass lies below 35 kilometers, and half of it within the first 5.5 kilometers above sea level. With increasing altitude, both pressure and density decrease rapidly, affecting aircraft lift, engine performance, and human physiology. Therefore, all aeronautical data are standardized against the International Standard Atmosphere, or ISA. According to ISA, sea level pressure is 1,013.25 hectopascals, or 29.92 inches of mercury. Temperature is 15 degrees Celsius, and the standard lapse rate is 6.5 degrees Celsius per kilometer up to the tropopause. The troposphere, extending to about 16 kilometers at the equator and 11 kilometers at the poles, contains nearly all clouds and weather phenomena. Above it lie the tropopause, stratosphere, mesosphere, thermosphere, and finally the exosphere, merging gradually into space. Understanding this layered, dynamic system is fundamental for every pilot, because the atmosphere is not just where we fly, it is what makes flight possible.